Hey there, welcome to Accurate Physics. In today's video, I'll be talking about the key points of Gauss's law. Gauss's law is one of the equation from Maxwell's equation. We know Maxwell's equations are fundamental understanding of electromagnetic theory, which is the greatest achievements of the 19th century. This gives you the basic understanding of electricity and magnetism. In one term, we can say electromagnetic theory. So to get started, the one of the most important feature is to be a part or an equation of the Maxwell's equation. There are four equations that constitutes Maxwell's equation. One of the equation is Gauss's law for electricity. So that's why Gauss's law is the one of the equation from Maxwell's equation. Second point is Gauss's law is a fundamental principle in electromagnetism. So this gives you the understanding of Gauss's law, gives you the understanding of the fundamental of electricity and magnetism. That's why to understand electricity and magnetism is important, because by understanding electromagnetism, we are able to create, we are able to build all kind of electronics. That's why understanding of Gauss's law is crucial. The third point, which is important while talking about Gauss's law, is it applies for electric and magnetic field. In Maxwell's equation, one of the equation is Gauss's law for electric, and another one is Gauss's law for magnetic field. One for electric field and another for magnetic field. So actually there are two Gauss's law in Maxwell's equations. So from the Gauss's law of electric field, we understand that there is existence of electric monopole. Single positive or negative electric charge could be possible. From the magnetic equation, magnetic field of the Gauss's law, we can conclude that magnetic monopole is not possible. So which is also greatest revelation, understanding or finding from the Gauss's law. Gauss's law holds true for any kind of closed surface. It doesn't matter what kind of closed surface is there, what kind of shape is there. Make sure if the surface is closed, we can apply Gauss's law. Other important points from Gauss's laws are Gauss's law can be utilized to derive Coulomb's law. Actually, Gauss's law is another way to derive equations as we derived from Coulomb's law, like electric field, calculating electric field, or force between two charges, potentials, and so on. That's why this is much better version of the Coulomb's law, which is very important, and it can be expressed in beautiful mathematics. And as I said earlier, this is a part of an equation from Maxwell's equation that constitutes Maxwell's equation. It will be interesting. It mathematically expresses the principle of charge conservation. So if we look at the Gauss's law for electric fields, it tells you that total electric flux coming out from a closed surface is equivalent to the enclosed charge divided by electric constant. That's why it gives you basically the principle of conservation of charge, right? Charge cannot be destructed or created. It's a principle of conservation of the charge, which is important revelation or fundamental understanding of electricity and magnetism, because you are understanding the very fundamental of electric characteristics of behavior of the particles. It is commonly employed to compute electric fields for symmetric charge distribution. In general, when dealing with problems related to charge, we can compute the electric fields of symmetric charge distribution. For example, spherical charges, point charges, linear charges, cylindrical kind of shape of charges, and so on. And another point which is also very important is it is founded on the inverse square relationship between electric field and distance. Because when you look at the relationship between the distance and electric field, from the source of the charge, for instance, charge is located somewhere in the space and you are trying to find the electric field at distance r, certain distance say r, away from that electric charge, it will follow the inverse square relationship. So these points are very important while studying Gauss's law for electric field and magnetic field as well. More detail about the Gauss's law related to magnetic field, I'll come up with another interesting video. Thank you.